Hello fans of GeoGebra. We have a lesson today on the basics of setting up a cantilever beam subjected to point loads, and we're going to take this in small steps, 4-minute videos or so, little bite-sized pieces. And in doing so we will get comfortable with this program. You don't have to use this program, but I can't imagine using anything else. So a couple of things. The one thing that students typically don't think of is that points must start with a capital letter. So let's say that we're going to call the wall 0, 0, and notice I'm using capital letters. Notice that the labels show up and the font is kind of small. So I'm going to go to Options, Labeling, No New Options, No New Label, sorry, and then Options, Font Size 32, and I'm going to right-click on the point and say I'm not going to show the label. One of the weird little bugs that popped up recently in GeoGebra, because it's constantly being updated, is that I feel like I have to close the algebra window and then reopen it to manipulate some of the colors and things in the graphics window. So I'll do that right now. I suggest that you do that also at once, only once. Close the algebra window and then under View, reopen the algebra window. Within the algebra window, you can organize your entities by dependency, so parents to children. I prefer object type. Okay. Everything else is sort of Windows standard. You could move things around as you want. The sliders, most students really like the sliders. They're just kind of fun and dynamic. I like them too. So I'll put a slider in for the tip length. I'll call that tip X to differentiate it from the point, which I will call tip with a capital T. And let's go from 0 to, it doesn't really matter, 30 in increments of 1, doesn't matter also. And then what I could do is create the tip point, again with the capital letter, is equal to, then parentheses, and now I could just say tip X and 0, and there it is. You could see the tip point moving. At this point, I'm going to close the, hit escape. I'm going to close the grid, close the axes, just so we have a nice clean palette. I will put a segment in here between the 2 points, and then I will hit escape so I'm back at my arrow. Touching an object and then right-clicking opens up object properties where I can change the color and the thickness. Notice it's a little squished on my screen. You could always resize this, so I sort of like to put it down here. I'm just holding my left mouse button, moving things around. So I'm going to change the color of the object. I like to make the beams blue. Big fat beam, lots of opacity. Okay, and then you could see it getting updated right away. I like to draw the parallel lines and perpendicular lines from the original axes. So I'm going to turn my axes back on. It's just a nice way of having a true vertical or a true horizontal. All the lines commands are under this fourth bullet, the parallel perpendicular. So I'm going to do parallel. Touch the y-axis, touch my left, touch that line, touch my right, escape out, and then I close the axes one more time. Now I can make a nice little wall at the left with my polygon. Since I have this line, it will snap to the line immediately. So here's my little polygon. I'm going to start at the left end, hit something on that line, and then just make a little wall. And come back to it. I like to hide these points. Don't delete them, because if you delete them, the offspring will be deleted, which is the polygon. So just hide them. So show object. I'm right clicking, show object. You could do this over here too with these blue buttons. You just have to sort of remember which one is which. You can hold your mouse, or I guess that's F. Okay. All right, and then, I could change the properties of the wall. And notice I'm down in here, maybe bricks. How's that? Nice. Okay. I will put in a load as on a slider. So I'll call that load 1x. And that will go from 0. And here's a little parametric idea. I know that I don't want my load to go bigger than tip x, so I'm going to say, hey, the maximum that you could possibly be is tip x. Increments of 1 is fine here. This could be 1 meter or 1 foot. It doesn't matter. So that's the x. And then another slider for load 1 magnitude, I guess you could say, and that can go from 0 to anything. It could be, let's say, 5,000, okay? Maybe in increments of 10. That could be kilonewtons, or it could be kips, or it could be pounds. It doesn't matter. Now, I want to show the load here on the beam. So I will create a point, and I'll call it load 1 point is equal to, and now can you guess what the next step will be? It will be this number here, load 1x, and 0. And notice it's blue here, so now GeoGebra knows what I'm talking about, and obviously it's on 0, and you see, boom, it just popped up. I could do a parallel line through here, and then this, sometimes students get confused about this, but it really is simple. It's not confusing at all. This beam might be 14 feet or 10 feet long or 13 meters or whatever, but this load could be thousands and thousands. So I have to have the load and the bending moment later drawn at some scale, some comfortable scale. It's just that simple. They can't be at full scale. So I like to draw my buildings at full scale in this program, and then everything else is scaled. The forces and the moments are scaled. So I will put in a slider for force scale, and you can call it whatever you want, and that will go from 1, which means there's no scaling, to something. It doesn't matter what at all. We could always adjust it later. And then I will put a circle in. I love this little trick here. You could put a circle in. There's a lot of different circular things. I choose the second one, circle and radius. And it's saying, if you ever need help, just hold your mouse over there, and it says, okay, select the center point and then enter the radius. So I'm selecting the center point graphically. And what do you think the radius will be? The radius will be the load magnitude, here, this one, divided by the force scale. Load 1 magnitude divided by the force scale. And here you could see now that I could change the scale to be, something comfortable, anything comfortable. This is variable. And then to draw the load, I just simply find the intersections. Of course, there will be 2 intersections to the vertical axis, but I'll just hide 6 o'clock and I'll keep 12 o'clock. The intersection button is here. And again, it says select the 2 objects. So I'm going to select the vertical and select the circle. And as I said, here's the second intersection. I'm going to hide that. Don't delete it. Just hide it. Hide the circle. Don't delete the circle. Even hide this axis. We could leave this axis for now. And then I'll put in a vector going from here to here. And that vector shows up here. It also shows up here, but it's overlaid on the line. So I could right click over here and hit Object Properties and make a big fat red force vector because forces are red in nature. And I'm even going to hide this point. I don't want this point. So it's super clean, super minimal palette. Here I'm moving the load, I'm moving the magnitude, I'm moving the scale. Very, very nice. Moving the tip, which doesn't affect that. And then obviously the moment in the wall, and this is where we will stop. M wall is, what is it? It's this load times this distance. So it's load 1 mag times, and a space bar is times, or you could put a star in there, load 1 x. And here it looks like it's animating. I sorry about that. Okay, so now the M wall is 12,400 force lengths. So again, GeoGebra does not use units. You have to keep the units straight. I'll show you a hint for the units. I did that in the load takedown, remember? And I could draw the bending moment diagram here really nicely, but I need a new scale for the M because now this is 12,000. So I will just put in another slider, moment scale, dividing by 1. Some people can multiply by a scale, but then you have multiply by 0.0005 or something. I think it's easier to divide by a big number. So let's make that 5,000 here. And then I'm going to make a circle here again for the M. We're almost done. Circle, center, and radius. It will be moment M wall, which you could see right here in the algebra window, divided by moment scale. And that looks a little uncomfortable. So here we go. That looks pretty good. Something like that. It doesn't matter. And again, the intersection between the circle and the vertical line at the wall, hide 12 o'clock because I'm going to, or hide 6 o'clock. I'm going to put it at my, on the tension side, as Euro cool people do. And it's a straight line from here to here. And I could even make a polygon if I want. Okay, and then I have my load 1x, my load 1 magnitude. My moment scale doesn't change anything. Notice M wall doesn't change. It's just this depiction of it. Let me show you one more trick here that's kind of nice. Not kind of nice, super nice. Under the slider, you could put in text, and you may say big deal, but you could put in dynamic text. So here, M wall is, that's just regular old text. And now I want this object to pop up. So I go under objects and I look for it. Here it is. And notice it's in a box and you could see the preview of it. Looks good. And then I like to put in the units here. If you're in Europe, you would use Newton meters. We are in the United States, so we have to use clunky imperial units, foot pounds. And that's kind of nice. And you could actually make that red if you want, or bold, or whatever. That text here, bold, maybe. It doesn't have to be red. Okay, so that's super sweet. We're done. Notice that it's updating the M wall independent of the scale. This is just a graphical representation, right? All right, thank you.